Section 4, range and standard deviation. So range and standard deviation are ways of measuring the spread of data, whereas mean, median, mode were ways of measuring the middle. The range is the difference between the largest data value and the smallest data value. Another way we write that is that the range is equal to the maximum minus the minimum. So if we want to find the range of this data set, I would take the largest number, 93, and subtract the smallest number, 1, and it equals 92. Standard deviation is the average distance that the data values are from the mean. The larger standard deviation is, the more spread out the data. So that's a good thing to highlight. The formula for a sample, because that's all we're going to be doing in here, population standard deviation, and is taught in a regular statistics class. So here's the formula. It's the square root of the sum of the difference of each value minus the mean squared divided by the sample size minus 1. So don't worry about that formula too much. We will use technology to compute standard deviations for the most part. However, I think it's nice to see what it looks like if you were to calculate it by hand, so you can see that it's awful and that technology is your best friend. So we're going to use that formula. I'm going to have a column for x bar, and we're going to do x minus x bar. We square x minus x bar, and then we take the sum of all the x minus x bars squared. So remember, x bar is our mean. Let's put a little note up here in case we forgot that. Now we're going to list all of our data. It doesn't matter if they're in order or not. 8, 16, and then I'm missing a row. So I'll just put that in with my 2 different color purples here to keep you on your toes. 3. All right, the mean of this is adding all the numbers together and divided by 2, so that's 15, or divided by 5. 15.9 divided by 5 is 11.8. So you just want to put 11.8 all the way down because the mean is the mean. Do the subtraction. X minus x bar. 17 minus 11.8. 15 minus 11.8, which is 3.2. 8 minus 11.8, negative 3.8. 16 minus 11.8, which is 4.2. And 3 minus 11.8, negative 8.8. So that first one, 17 minus 11.8 is 5.2. Square all of those. So 5.2 squared is 27.04. I'm just rounding to 2 decimals. 3.2 squared is 10.24. Negative 3.8 squared is 14.44. 4.2 squared is 17.64. Negative 8.8 squared is 77.44. Note all of these values are positive. Whenever you square a number, you always end up with a positive value. However, if you type negative 3.8 squared in your calculator, it will give you a negative 14.44. So just make sure that you put the number in parentheses so that you get the correct value. All right, now if I add all of those values together, it comes out to be 146.8. And that's the same all the way down. So I'm just going to draw an arrow. And then finally, we're ready to take the square root of 146.8 and divide it by n minus 1, which is 5 minus 1, or 4. And when you do that, you should come up with 6.0581. Gosh, I can't read numbers anymore. 6.0581 is my standard deviation. Okay, so that's how you calculate it. Or you can use technology. There's Excel that will do it for you, and there's plenty of online calculators. All right, so this next example kind of gives you an idea of what it means. So Fredstone Pizza has 2 delivery drivers, Mindy and Patty. Due to an increase in orders from third-party delivery websites, the owner, Fred, can only keep 1 in-house delivery driver on staff. Fred looks at the deliveries that Mindy and Patty have made over the past month. They both complete their deliveries in an average time of 20 minutes, but Mindy has a standard deviation on her deliveries of 4 minutes, while Patty has a standard deviation on her deliveries by 12 minutes. If Fredstone Pizza offers a 30-minute or free guarantee, which delivery driver should Fred keep on staff and why? So because Mindy has the smaller standard deviation, Mindy has a standard deviation on her deliveries of 4 minutes. Patty's was 12 minutes. So we probably want to keep Mindy because she's more consistent. Having a bigger standard deviation means that Patty's numbers are a little bit more all over the place. And if her average is 20 minutes and her standard deviation is 12, that means she's going past 30 minutes sometimes, which would mean that they'd have to give the customer a free pizza.